Hello, this is SCP questions. Sorry, this is SCP questions number 2, and state the relationship between magnetic force and separation distance. As you know, equation electric force electrostatic force F is equal to K Q1 Q2 over R square. So this is related between two charge and the distance, and the separation distance, when the separation is increased, so F decrease. This means F is inversely proportional to 1 over inversely proportional to the R. So R and F, this is R square. And number 2, describe the direction of the force E2 on the E1. E1 is negative and E2 is negative, so this is repulsive force. So the force by the E2 on the E1, the direction is to the left. So the E1 here, direction by the E2 is to the left. And the second is P is proton positive, so the force by the proton P positive on the E1, the force by the proton P positive on the E1 is direction to the right, because this is negative, this is positive, so attractive force. And good. So we go to the number 2. Number 2B. So experiment A. So use a 2 Q naught and Q naught. This means if you refer to the so the question asks you about the electric field. So electric field, according to the equation, electric field E is equal to K Q over R square. That means if you have the charge Q, let's say positive Q, and you have a test charge, let's say Q naught. So the electric field here, electric field by the positive Q is related to the charge Q, not related to the Q naught here, according to equation. This means if you use a positive 2 Q naught or positive Q naught, the E here is depend on Q, depend on the charge Q, not depend on the 2 Q naught and Q naught. Okay. Number C, so you have a point R and T, and this is positive Q, this is negative Q. So the question asks you, what is the work required to move particle from R to T? So what is the work done? So equation to the work required is equal to Q, charge particle Q, times potential difference between the 2 points, point R and point T. So you must calculate what is the value of VR and what is the value of VT. So VR here, equation potential difference is equal to V K Q over R. So at the point R, potential is come from the positive Q and negative Q. So this is equal to K positive Q over the distance is T, and you have a plus potential difference at point R because of negative Q. So you have a K, and negative you must include the equation negative Q over D. and potential at the T, same procedure is come from positive and negative Q. So this is K from the positive Q over D, distance D, and come from the negative Q plus K negative Q over D. So if you leave the two equation here, this is two value KQ, 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 but this is negative, so that's me cancel, 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 cancel. So all the VR is equal to VT is equal to 0. So according to the equation, what done to bring charge from R to T here? So what done is equal to Q is Q, but the value of delta V here, delta V here is refer potential difference at T minus potential difference at R, but Vt is equal to 0 and VR is equal to 0. So what happened to the W? W is equal to 0. That's all. Thank you.